management expert with over 20 years of experience in designing world-class enterprise architectures for government and public sector, financial services, retail, telecom, healthcare, energy and electronics industries, and building digital innovation labs for Fortune 500 MNCs such as PwC, EY, IBM, UST Global, etc. He's an advisor to startups, think tanks, non-profits, and entrepreneurs across the globe in emerging technologies and exponential business models. Mr. Gokul is the founder of Epic Knowledge Society, one of the largest emerging technology and exponential entrepreneurship focused non-profit organization with the roots in India and serving thousands of engineers and educators across the world. He has joined Station Lab as the Chief Innovation Officer, focusing on FinTech and RegTech through the Conference of Cryptography, Consensus Algorithm, Data Science, and Distributed Ledgers, and also guiding blockchain entrepreneurs across the world through the international venture capital platform, Blockchain Founders Fund. He is recognized as a global thought leader in FinTech, HealthTech, EduTech, RegTech, Big Data, Blockchain, Cloud, Cybersecurity, Data Science, Quantum Computing, Post-Quantum Cryptography, etc. He has successfully implemented enterprise portals and content management systems for Citibank in 64 countries across the US, Europe, Asia, and the Middle East. Mr. Gokul has published 4 patents and authored articles across international magazines and portals. He is an IBM certified architect and IBM Red Books author. He also has authored a book on blockchain security. He has advised several academic institutions such as University of Kerala, University of Madras, MT University, Vellore Institute of Technology, Jain University, etc. He has worked with MIT Media Lab on open access algorithms and quantum computing. Mr. Gokul has introduced pioneering blockchain protocols such as Algorand, Eternity, Elixir, Hashgraph, Horizon, Exos, and Zcash in India. He is a member of international forums such as Cloud Security Alliance, Enterprise Ethereum Alliance, Wikimedia Foundation, and Hyperledger Foundation. He loves the creative convergence of programming, physics, poetry, psychology, and philosophy. And with great pleasure, I invite Mr. Gokul Alex for the hands-on session on Corda. Over to you, Mr. Gokul.
Thank you so much, ma'am, for the kind introduction. It's a great pleasure and privilege to take this session for the AICT short-term program organized by Saintgits College of Engineering. Am I audible to you, sir?
Yes, yes, you are audible.
Yes, sir.
Okay. Thank you so much. I'm just logging into my machine. Please let me let me share my screen shortly.
Okay, sir.
So we will first start with some of the essential concepts related to Corda, and then we will move on to the hands-on demo. I'm just sharing my screen. Hope you can see my screen.
Yes, sir.
Okay, so first we will get started with the Corda platform. I have my Corda server running in this machine. Are you able to see the command line?
Yes.
Okay, so in this, this is my environment. Please let me know if the font is not visible. I'll change the color and the terminal preferences. Is this okay for you, or should you want me to change it? I can change it to something else.
Yeah, it's okay.
Sir, just increase the font.
Yeah, let me do that because I've used it for my personal reasons when I'm spending too much time on the computer monitor. Okay, so I'll start my monitor once again. Is this visible to you?
Yes, sir.
Yes, sir.
So I will log into my machine and will show you. So I'm just logging. I have a environment where I'm running Corda applications. So I'm just moving in there. You can see my Corda sample applications. We will be using some of this sample applications for today. Are you all, is there anyone using Linux machine or all of you are using Windows machines?
It's a mix, sir. It's Linux plus Windows, sir.
Okay, fine. So, we will first get started. I will tell you how to start the environment setup, and then we will get into the theory session. Okay, so that you can start the environment setup first. First, what we need is you will need. Let me first tell you what the Corda is a ledger and a network. The key concepts that we will study are in Corda ledger, we construct the ledger out of state objects. So Corda is written, in combinations of Java and Kotlin language, primarily in Java programming language. So all of us know Java is an object-oriented language, right? So the ledger, I'm sure all of you are familiar with the concept of digital ledger and decentralized ledger. So we are dealing with the different kind of ledgers. You must have gone through other ledgers like Hyperledger or multi-chain, Bitcoin, Ethereum, etc. So this is a ledger written in an object-oriented language, and hence the primary object in this ledger is state object, and then we compute the state and do transactions, and contracts govern the way in which states evolve over the period of time. So if the data model of Corda is such that states represent shared facts on the ledger. Okay, and transactions update the ledger state. So if you want to update the ledger state, you need to do transactions. And contracts are constructed for manipulating or managing the states over a period of time. So real-time state update happens through transaction, but through a period of time, a period of a particular activity, you want to update the state, you can use the concept of contract. And when we want interactions to happen between parties using this ledger, we model it on the basis of flow. So the principle of Corda platform is there are three main tools to achieve a global distributed consensus. If you are not familiar with any of the term that I'm using, you can mention that in the chat, or you can ask questions. So I hope you are all comfortable with the concept of a global distributed consensus. Here we are dealing with a distributed system, a distributed computing environment, and we believe we have a global stabilization time. All this all these systems which are part of the distributed system are sharing a global clock. That's why they are called a global distributed consensus. And hence, there are broadly two models for distributed systems. They can be either asynchronous systems or synchronous system, or they could be in between, called partial synchronous systems. Most of the cases, distributed systems such as ledgers, right? Distributed ledgers are considered to be partially synchronous because they are using a consensus to agree on a shared state between parties. So it is important to understand the concept of a global distributed consensus. And there are three tools used in Corda. One is smart contract, and it is written as a logic, business logic, smart contract that specify constraints that ensure state transitions. So we have to remember these terms. Smart contracts are written in a way that they enforce constraints on the state transitions, and they verify the validity of them according to pre-committed or pre-agreed rules, which is written in the contract code as part of the Corda. Corda, the applications that we develop in Corda are called Corda. And there are services known as uniqueness service and timestamping service. These are very important for the Corda distributed system. And they function as the notary pool for ordering transactions temporarily and to eliminate conflicts. So importantly, Corda has conflict resolution data types. Okay, and see the concept of CRDTs, conflict resolution data types, are very important in the modern distributed systems. So we have the concept of ordering transactions temporarily through using verifying timestamping and uniqueness, which are two important parts of the Corda services. They are collectively known as notary pool. And Corda uses a particular workflow framework known as, or a state transition framework known as flow framework, that simplifies the process of writing complex multi-step protocols. It's very important to understand we are using multi-step protocol. It is not a single phase commit, like in the case of some of the databases, right? We have 2-phase commit and 3-phase commit and multi-phase commits. That's why it's called multi-step protocol. This multi-step protocol helps us to write complex business logic between mutually distrusting parties over internet. This is very important to understand. So Corda, when you look at from above, the architecture from above looks like this. The Corda marketplace where you build your apps are the apps which will expose Corda services. Underneath we have platform services, vault services, and node services, and then some operational services and integration adapters. Before deep dive to them, let us see how to set up Corda. Right, when you set your Corda network, right, the basic requirement is you should have a Java 8 Java development kit. All of us know Java is going through a lot of changes now. Until Java 8, it is a single version, but from Java 8 onwards, there are open JDKs and closed JDKs. Oracle offers a set of enterprise licenses, and open source environments are provided by different other players. Like open JDKs are from Red Hat, Zulu, IBM. A lot of them provide open JDKs. So Corda is still running on Java 8, and also for writing code in Corda, we use the utility called IntelliJ. IntelliJ is this is like Eclipse. This is the IDE, Integrated Development Environment, that offers strong support for Kotlin and Java. So IntelliJ is the recommended IDE for Corda. This is from the company known as JetBrains. And then you should have the Git source code control, version control protocol installed in your machine. You should also have Gradle. Gradle is the release management, build and release management, package management utility. You should have Gradle, and then you can start with your first Corda app, right? So I hope you have installed all this. Please let me know if you don't have any of this environment. So I will share this link to all of you in the chat so that you can install this environment. So you can get started with the environment setup. I have given the link here. Okay. And then once you have, so once again, you should have Java 8 in your machine. You should have a IntelliJ IDEA. You can download IntelliJ IDEA. You should have Git also installed in your machine. You should have Gradle utility. And then once it is there, you can install a Corda. Then I will guide you to this. So we will get started with it after understanding the steps in the theory. Okay. So once you have installed all this, IntelliJ IDEA, you can do it parallelly, but it is important you should have JDK. First, you should have JDK, Java 8 JDK, Git, Gradle. These are essential. You should start downloading IntelliJ. It will take a little bit time. If your JDK also may take some time if you don't have JDK. So you can get started with installing IntelliJ IDEA. Git and Gradle installation will be faster. Once it is done, we will get started with the demo. Okay. But either ways, I will show you the demo, but after seeing some of the concepts. I hope it is okay for all of you. Any other comments?
Yes, sir.
I have sent a link here. Can you? Oh, I think I've sent only to one person. Everyone. Okay. Yeah, everyone. I've sent to everyone. Now I hope everyone can see the link.
Yes, sir.
Okay, great. So we'll get started. All of you can follow the link, install Java 8 JDK, Git, Gradle, and IntelliJ. Okay, cool. Let's get started. If you have any questions, you can ask in the meantime. So let's get back to the presentation. Here we are seeing, when you look at the overall architecture of Corda, it consists of platform services, vault services, node services. These are the core components. The platform services consist of important services at the Corda ledger level. How do you develop the dApp, core dApp? And then there are some specific services to fetch data from the real machines. Like if you want to do a ledger for IoT, if you want to fetch the data from some market feed or some other real data stream. So for example, you are building a ledger for satellites. Then you can use the second component shown here. It's called Oracle. Oracle is the name used for any black box Oracle is the word name for prophet, right? It's synonymous with prophet. It's not the Oracle company. Oracle is the prophet in word sense. It's a black box through which you fetch data from physical data source into the ledger. Then we have notary service. Notary service is taking care of timestamping and uniqueness validity of services. We mentioned we need some components to verify transactions. Notary works in that way. Then there is another service known as network map service. Network map service deals with taking care of the Corda network. We mentioned Corda is not only the ledger, Corda also consists of the network of all the node which are interconnected. And then we also do reporting, because most of the times Corda is for financial ledgers. Reporting is very important. And there is a communication gateway between node in Corda. That is why it has a gateway. Then Corda has another additional gateway for integrating additional services. These are the platform service. So that Corda offers across the node. Then every node has a dedicated vault, a vault. So this is very different from other blockchains like Ethereum, Bitcoin, Hyperledger, etc. Corda is not a replicated state machine. It is very, very important to know the difference. In Corda, every node maintains their versions of data in their vault and their database. Corda does not do data replication between node. Corda also doesn't do gossip between node. So it's very important to know. Many blockchains like Bitcoin, Ethereum, Hyperledger, all of them uses gossip protocol. In Corda, we use something like a different messaging protocol called AMQS. I will show you the details of it. So it's very important to know Corda doesn't do gossip, and hence the size of the ledger is comparatively smaller. It doesn't have the redundancy and replication, data replication. It doesn't do real-time data synchronization and real-time data replication. It also doesn't do broadcast of the block between the node. So in that sense, it is not a strict blockchain data structure as in the case of Bitcoin or Ethereum. It is a different kind of a ledger. But Corda also has the concept of distributed node. They also have the concept of smart contract. They also have the concept of verified transactions. They also use the Merkle tree. They also use the data model like Bitcoin called UTXO, unspent transaction model. I hope you are familiar with these terms. If any of these terms sound non-familiar, please let me know. If you are not familiar with the concepts like UTXO, or if you're not familiar with the concepts like Merkle tree, please let me know, because these are the fundamental concepts of blockchain you should have clarity in. Okay, now getting on to the next part. Corda also has node services. So node services means what you do at the infrastructure level in a node. There is a sandbox. There is a digital signature. Okay, I will briefly explain these terms. There is a comment from somebody about the terms like UTXO. I hope you have seen the terms like Merkle tree. But if you want me to explain, I can do it. UTXO, I will explain. So UTXO is called it. This is a model first time invented by Bitcoin protocol. It's called unspent transaction. This is how the term is explained in Wikipedia. I'll show you the small diagram also. this is the model. I'll show you the diagram first. So when you do a transaction, the input of the transaction is, so it's like this data model means you consider the data as you basically consider the data as a input-output transaction. For example, just compare with a wallet. When everyone use a purse or a wallet, right? In wallet, before we do the transaction, we have some amount of money. That is called input. And when you do a transaction, you spend some money, and the balance of that money, for example, if you have 100 rupees before the transactions, and if you're spending 30 rupees, you take the 100 rupees, do some transaction, you pay, get the balance 70 rupees and keep it in the ledger. So what you track is what is left. So if you had 100 earlier, and after transaction, if you have 70, you track both 100 and 70. That's how you maintain the list of unspent transaction output. So every on-chain Bitcoin transaction is sending Bitcoin to one or more address. So then if the wallet or the wallet in which you maintain the transaction history is the sum of unspent transactions, which is controlled by the private key of the wallet. Wallet is nothing but where you hold your cryptocurrency, or where you, broader terms, this is where you maintain your transaction. Yeah. So I'm explaining UTXO. Hope you are understanding it. So it is called unspent transaction output. It is a model for the data structure in a transaction. So basically, it is one of the most important concept in the blockchains like Bitcoin, Corda, etc. The size of the ledger in the Bitcoin is mostly due to the size of the UTXO. UTXO represents a chain of ownership. Chain of ownership means who own the data, the block that you write. So in a chain, every block contains series of UTXO. So if you are doing 20 transactions, you will have 20. I will open this image. Let me show you the image, a good image. I think this image shows it clearly. I think you can see this image clearly. So every transaction has an input. Input comes from whoever is giving the input to the transaction. Then the output will be recorded after the transaction. So every input of the transaction will refer to the output of the previous transaction. You can also, every input refers to its output. Input from the next block also refer to the output. So the size of the block is due to the size of the UTXO. And every UTXO is digitally signed in a block. So the size of the UTXO determines the overall size of the block. Okay, I hope this concept is now clear to all of you. If you're having any questions, you can raise it again. So we'll get back to the presentation. Okay, so I think we have covered the concepts like, yeah, so I wanted to summarize. Corda is different from other ledgers, but it is also similar. So you should understand the similarities and difference. Similarities, Corda also uses the concept of UTXO from Bitcoin. Corda also has the concept of smart contract from Ethereum. Corda also has the concept of distributed node in the case of other protocol. Corda also has the concept of vault, which is present in other ledgers like Algorand. But Corda is different from Bitcoin in the sense that Corda doesn't create a Corda doesn't use something like a proof of work for consensus. Corda uses
Notary services.
Yeah, exactly. So I'm just saying, spent and unspent, and spent and unspent. There's a question, Mr. Muhammad, Mr. Muhammad Neeman. The question is, spend and unspent, how is it classified? See, spend is identified when you have an input coming in, and then you do a transaction with the input amount, and then you get the balance in your ledger. That is the output. So every block has an input and an output. I mean, when you enter a transaction as a proposal so what happens in a block is normally in large blockchains, you group transactions. Let us imagine if you are doing a small blockchain, you have only one transaction per block. If that is the case, you have only one transaction in a block. When you add the transaction you propose with an input amount, then you do the transaction and get the output amount. And this output is referred by there is a relation between input and output, and the next input also refers to this output. That is how they are related. So more than classification, it's a relation. Every output is linked to its input, and every output is linked to the next input also. That is called UTXO. Okay, now we come back to difference between Corda and other ledger. Corda doesn't use the consensus like proof of work and proof of stake that is used in Ethereum and other currencies. Corda also doesn't use the consensus used in ledgers like Hyperledger. Like, it is not strictly Byzantine fault tolerance. You must have heard about the term Byzantine fault tolerance. If you have any questions on that, I can explain. This is the consensus. The concept of crash fault tolerance and Byzantine fault tolerance are some of the foundational concepts in distributed computing, which are very importantly referred and used in blockchains. So the tolerance of a blockchain against crash of a node is known as crash fault tolerance. Tolerance of a node to a malicious attack or a malicious node is known as Byzantine fault tolerance. So these two are strict requirements for distributed consensus in a blockchain. Corda doesn't enforce this Byzantine fault tolerance very strictly, but they follow a different model. And consensus Corda is different. The way they design and implement smart contract is also different. They also use flow framework, which is not there in other distributed ledgers. So these are very, very different. So, but the similarity is Corda used the concept of smart contract. Corda also used the concept of UTXO. Now let's get back to our presentation again. Okay. So now, if you summarize the points that we have mentioned here, Corda uses tools like Kotlin. Kotlin is a very efficient program language derived from Java, very popularly used in Android and also used in Corda. Corda uses Gradle for build. Corda uses Git for version control, IntelliJ for the development environment, and you can also use command line. And Corda uses Oracle JDK 8. Corda's main components are states. States are immutable, shared facts between parties. It uses contracts to help states to evolve and to control the states. We can do transactions in Corda, making state change possible. Corda also uses flow framework to manage successful transactions. Corda uses consensus called the validity and uniqueness consensus. So that is important. Corda node manage the flow through Corda app. So Corda, every Corda app is Corda is connected to Corda node. So there is a good infographic from 101 blockchains on R3. R3 is the company that has or the firm consortium that has brought in Corda. It's a enterprise so blockchain company. They have more than 200 members from multiple industries, and quite large number of developers are working with them. They we heard that they use smart contracts, timestamping, and flow. Corda has some principles for Corda's architecture principles are scalability, longevity of transactions, security of transactions. So, you know, the interesting thing is I have deployed Corda on 4.4 version, 4.1 version, and 3.1 version at the same time. That is a very interesting, you know, approach from Corda. Corda supports long-term releases. Yeah. So there is a question on how different is Corda smart contracts from other smart contracts. So for example, there is a concept of Turing completeness in smart contracts. You know, Turing complete smart contracts and Turing incomplete smart contracts. This is the main classification. So when you have smart contracts which are Turing complete, they're very flexible. You know, the concept of Turing machines, right? So Ethereum supports Turing complete smart contracts, which are very flexible. Like you can do recursion, you can do a lot of loops, and you can do different kind of logic, right? Different kind of logic in a Turing complete machine. But a Turing incomplete language or Turing restricted language doesn't support all those features. For example, Bitcoin, there is a debate, there is a long-standing argument about whether Bitcoin is Turing complete. Many people like Craig Wright, who allegedly said he himself is Satoshi Nakamoto, but many people don't believe he is Satoshi. That Mr. Australian computer scientist Craig Wright famously said Bitcoin is Turing complete, but many people doesn't agree to it. Ethereum is designed to be Turing complete, but then Corda, in the strict sense, Corda smart contracts are not Turing complete in the strict sense. And another difference is the kind of the way the smart contracts are compiled into the virtual machine. In Ethereum uses a stack-based virtual machine, stack-based model for virtual machine. But Corda uses Java virtual machine. Java virtual machine is not stack-based virtual machine. It is a registry-based virtual machine. And hence, that is one primary difference. The way the smart contract its instructions are executed in a stack-based virtual machine is different from a registry-based virtual machine. The stack-based machines are traditionally faster. Traditionally, the way they are written, there are two kind of notations like Polish notation and reverse Polish notation. The notation in which the code is executed in the stack-based virtual machine is different. Corda doesn't use stack-based virtual machine. It uses registry-based virtual machines in Java. So this is a very evident difference. One is the Turing completeness of the Corda smart contracts is questionable, not clear, and they are not claiming it either. They don't claim to be Turing complete, whereas Ethereum claims to be Turing complete. And secondly, it is not a stack-based virtual machine that is used in Ethereum or some others. Okay, now coming back to the architecture standards, it is given so much of importance to security. Corda is said to be applying some of the cryptographic libraries that makes it post-quantum safe. So the kind of cryptographic libraries used in Corda claims to be able to protect even from a possible quantum computer attack, a quantum powered adversary. And Corda gives so much importance to interoperability. That is why Corda has done projects integrating or integrating with Hyperledger Indy, Hyperledger Fabric, and Ethereum. They give so much of importance to interoperability. Perhaps the way they have written in Java also helps them to be very interoperable. And then there are a lot of other business principles like financial inclusion, focus on providing identity for every transaction, giving privacy. Corda's main strength is its privacy, because every node can maintain its own separate history, its own versions in its vault. It's a very big advantage. And then smart contracts will give its facility to do shared logic and legal footing. Corda's smart contracts are legally enforceable. That's why I've seen many governments, many financial organizations, many regulatory organizations supporting or using Corda for the using Corda for using Corda for transaction, because the contract you write in Corda, it's easy to enforce. So there is a question, why not Turing complete? There is a reason why many languages are not written or engineered to be not Turing complete. The reason is the main reason why they are not written to be Turing completeness is with Turing completeness. When you give so much importance to Turing completeness, some scenarios, right? There is a problem like halting state problem in Turing machines. If you don't give so much formal verification, you may end up in getting your code into an indeterminate state. That is the reason many languages doesn't give importance to Turing completeness. So and mainly Java's latest lot of features that is introduced in the latest versions of Java, right? Java is now actually a kind of mix between functional programming and object-oriented programming. So, so in that sense, Java generics, there is a claim that the Java generics and Lambda expressions are Turing complete. So essentially, a Turing complete system means a system in which program can be written that will find answers. So it means it can solve any computational problem. That is the Turing complete sense. But then, in that sense, Java is now, since Java has evolved over a period of time with a lot of features, so we can say that they have not given so much of importance to Turing completeness, although there are some features which are resembling the Turing machine model. Okay, I think that is the good explanation. And then other points are immutability. They give so much of importance to verifiability of data and immutability of data. Now, when we move on, let us see some of the use cases in which Corda is used. Corda enables financial transactions like post-trade processing, auctions. I have personally deployed a real-time auction and reverse auction system on Corda. And I've also did the identity management system on Corda. I've also done it. But then there are other solutions like trade and settlement, supply chain reconciliation, and security settlement, cross-border payments, payment and settlement, settlement and reconciliation. These are some of the use cases. Like finance supply chain also, we can do settlement and reconciliation, insurance claims processing, claim verification. These are some of the use cases in insurance. One of the largest insurance consortiums, B3I, is built on Corda. And also it can be used in medical record management in healthcare. Governments can do a lot of transactions for identity and assets and benefits in using Corda. And law enforcement agencies are also using Corda for different use cases. One of the main advantages with using Corda for government is Corda's cryptography is the one which is highest rated by US government's National Institute of Standards and Technology. They have even rated Corda more than Hyperledger and Ethereum in terms of their compliance to the recommended cryptographic libraries. Some of the main consortiums built on Corda are Marco Polo, done mainly by R3 and TradeX, B3I Insurance Consortium by R3 with Alliance, and a lot of other insurance companies. Voltron is another financial ledger. Risk Block Alliance is another ledger of financial and risk management companies. So Corda, when we look at the Corda ecosystem, a lot of leading companies have come on board Corda, like Microsoft, Accenture, AWS, HP. They are all doing applications on Corda. So, some of the early implementers of Corda are SBI Holdings in Japan, ING Bank, and Maersk, and NatWest, SGX, Chain. That these are all examples of early adopters of Corda. So Corda is a shared ledger inspired by blockchain data structure, and so it's a unique shared ledger. It's blockchain inspired, and then it is developed for enterprise grade applications. Corda enforces consensus, distributed consensus, achieved at individual level. That is important. Every node, the consensus is enforced at an individual level in Corda, more rather than at the system level. And they also support variety of consensus mechanisms. The uniqueness and the validity consensus that gives a lot of security to transactions in Corda. And they have given so much of focus for regulators. Regulators can audit it. There are so many out-of-the-box features in Corda that makes it easier for regulators to audit transactions on Corda. And the Corda smart contracts are very customizable and very, it can be written as per the need of the requirement from the attorneys and the notaries and the legal professionals. And integration of Corda, since it is, Corda by default gives you a basic database, but then you can change that to PostgreSQL or Oracle. That is very flexible. So Corda's database can be changed, and a lot of flexibilities are there. Corda can be easily integrated with Kubernetes or Prometheus. These are the benefits. So when you look at the Corda architecture, this diagram summarizes the Corda architecture beautifully. Like we mentioned, Corda is exposed to the world as a network of node. There will be notarized node and a non-notarized node. So not every node need to be notaries. There could be notary node and non-notary node. So notary node will be separate and other nodes will be separate. Corda also uses some other infrastructure services called network map services and doorman services. These are the services at the infrastructure level. Every node consist of Corda apps and Vault. And the applications that you write in Corda communicate to each other through flow framework. So every application consists of state objects. State objects will have a UTXO, input output reference. You will have the details of the participants and their signature. You will also write the properties of the state, and then you initiate the transactions like the input output model that we mentioned, UTXO model. You initiate the transactions, and then flow framework make sure that your transactions are written into the node and the ledger in a sequential structured manner. You initiate the transactions, you build the transactions, and then it is verified. Once it is verified, you can have multiple subflows. You can initiate so a workflow can consist of multiple subflows. So you'll have multiple subflows, and then you can gather those multiple subflow, and then you can do multi-signature or counterparty signature. You can enforce that multiple parties need to sign a transaction, perhaps like a land registry, where you want the deeds or the transfer of titles and ownership when multiple parties sign it. So you can initiate counterparty signature. And then finally, after building and verifying and preparing the subflow, you get the counterparty signature and sign the transaction. Then you can do it for all the subflow. Finally, you do the finality flow. So this is how you look at the summary of Corda. So the key concepts we have seen earlier: state objects, transactions, consensus, and flow. So states are immutable objects. We have seen how UTXO model works and how do you do shared facts. Transactions consume input state and create output, just like Bitcoin. The newly created output state replaces the input state, and the consensus is done when parties reach agreement on the evolution of the shared fact. So parties look at how the shared state objects evolve over the period of time, and they reach consensus on it. They test the validity by verifying the contract. So validity and uniqueness, these are the two consensus. First, we will check if it is a valid consensus. Then we will check if it is a double spending or is it a uniqueness. Uniqueness is checked by the notary. So that is important to understand. Validity is checked by means of verifying the contract code, and the uniqueness is checked by the way of notaries. So there is an interesting comment apart from yeah, that's a very important point, Rohit. Yeah, you have mentioned it. Yes. So yeah, apart from the technical difference, the smart contracts in Corda are treated differently. Even if the smart contract validations are through, the node is not obliged to endorse, sign a transaction proposal. In most of the stack, smart contract validations go through, eventually hit vault. The last statement is not very correct. There is no concept of vault in other smart, not every blockchain uses vault. There are only very, very few of them which uses the concept vault. So smart contract entering a vault is not a common or a universal situation. But the important point that Rohit pointed is mentioned is very interesting. The node or the counterparty is not obliged to endorse or sign a transaction or proposal. See, even in the case of Bitcoin, you can say, even if you, in the case of Bitcoin, you propose a transaction, validators have they have the power, they can reject it. So this is a model which we can see in many ledgers. So, but good that you highlighted that point. It's interesting. So we will move on. Yeah, in a Corda network, A Corda network is an authenticated peer-to-peer network. Every node is a Java virtual machine. And we have a runtime environment hosting all the, so every, in a runtime in a JVM, you host the Corda services and execute applications as Corda apps. And a Corda network is, you can visualize it as a fully connected graph. Very importantly, Corda doesn't do a global broadcast. Corda doesn't do global broadcast or gossips. Communication occurs between on a point-to-point basis. And Corda uses a protocol known as AMQP 1.0 over TLS. And network map, it is important to know, network map is a service used internally in Corda, which publishes the list of active peers. And then when you look at the graph, the edges represent the potential to communicate, but it doesn't persist connections. Okay, so when you look at a Corda network, in a Corda network, we can, we have a single, so you can build networks with node and, so this particular diagram shows you a simple consortium between multiple banks. You can construct a network with multiple banks, and you need to have a notary, doorman, gateway, and an oracle. We mentioned the top point of oracles earlier. Oracles are connecting to external services. So when you connect to external services, you get the data. You get the data, or you want to verify something externally, you can use Oracle. So a network consists of the ledger, and then there should be an operating entity which takes care of the ledger, and applications are hosted on this ledger. These applications are termed Corda apps, and you configure the network parameters at the node level. Like we mentioned, we have multiple node, a doorman node, at least a notary node, oracle, and messaging gateways in a particular business network in Corda. We have seen these concepts, and there are advanced concepts which we mentioned. We use consensus, notaries that ensures uniqueness consensus, which prevent double spending, vault that store on ledger facts for a node. Some of the innovative features are time windows. Time windows are transactions. Time windows are transactions validated. So it's like an expiring transaction. You can set the expiration time of a transaction through time windows. This is similar to the concept of time locking in cryptography. It is also implemented in Bitcoin as hashed time lock contracts, HTLCs. So time window is a feature available in Corda. Advanced, another feature is Oracle. So to include off-ledger, off-chain facts, you can retrieve them or collect them from using Oracle. Then there is also the concept of transaction tear-off. Transaction signed by parties with limited view are called transaction tear-off. So these are the advanced features in Corda. And we also have mentioned about network map services that maps each well-known identity to node identity to an IP address. These IP addresses are used for messaging between nodes. For any inter-node communication in Corda, we use network map. Node also generate confidential identities for individual transactions. So before going further, probably we'll get back to our environment and see how to set up the environment. So I mentioned that, let me check. sec. Okay, let me reconnect. Okay. Two 239.234. Two 239.234. Two and three. So, this is an example of a Corda app that I have downloaded. The download process is very simple. What you do is you basically, I've set up a Corda node, local node manually. I've downloaded the Corda jar file. So basically what you do is we have to download the jar file of Corda. I'll just pass on this step here in the chat window. So what you do is you need a jar file. There is a configuration file, node conf. We will see all of them. First, I will show you how do you download it. Basically, yeah. So when you set up the network, you should have IP address, all those things you will have. You should have port forwarding, all this environment details you should have. By default, all of this must be available on your environment. So basically, this is an example of, okay, I will just show you this. First, let me show you an example of running a Corda sample application. So this is the application which I'm showing you now. So the example of running a Corda app. Let me give that here in this. Yeah, so I've just given you this link. So after downloading it, what you do is when you download it, this is the build structure. It is mentioned here. So you can open up your app in IntelliJ, but I am just showing you how to deploy it. So when you open up your example, you will see the detail. You will have a, like in Java, right? You write the client. So the client is the application that interacts with the node. So the client code is there and client properties are there. And then the log configuration files are there. Then you will also see a folder for the contracts. Contracts are written in example both in Java and Kotlin. And build is done using Gradle. And it uses a particular library called Quasar for running the workflow. And you can see all this build workflows here. Workflows are written in both in Java and Kotlin. So you will run your node by using Gradle. So this is what I'm going to do and show you. So this is the command to deploy the node. So if you're using Windows, you don't, in Linux, this is how you run the node. In Windows, you don't need to use the tab. So when you run the deploy command, what it does is it is doing the process called bootstrapping, and it is starting the network and building the node. It is so as per the whatever you have given in the node configuration, it will read the node conf file, generate the directory for each parties. So whichever parties we mentioned, we have notary and non-notaries. Non-notary nodes are mentioned as parties. So you see party A, party B, party C. So party A, party B, party C, and notary are created. Then it will create the distribute the all the node file to every node, generate the identity of the node. So you can see the it is following a particular configuration for identity. Then it will generate the Corda app whitelisting, and then what it does is it will run the build. So after running the build, when you go there, you can see that you can go inside your build directory. Then you can see your, let's go to nodes. Then you can see all your nodes. So you are inside your example. You run after running the build, you're going into build node. So here we can see all your node. If you're opening one of the node like party A, so only you do some transaction, you will see it here. Otherwise, there is nothing. Now let us go back to the common directory. So you can see your, when you go to your Java source, if you go to your source, right, let's go to source. So here, when you go to your main, you can go to your Java. You can, from here, you can see example code. So here, when you are inside, so when you are inside your Java package, Java source, you can see code for state, code for schema, code for flow, contract, client, and APIs. So every code that you write for your Corda app will be written into this location. You will write into the location. Yeah, so this is the location to which you write all the code. So we will go through all the code. See, let us open it online so that you can see it better than the, let me open it in GitHub. So this is an example. This contains more samples. If you want, okay. So I think the simple repo example is here. This is the one we have seen earlier. So here, if you are inside the source, you can see your code. You come to your example, all your code, so when you do a project, Corda project, all your code will be packaged in the form of state, schema, plugins, flow, contract, client, and APIs. So if you go to state, this is a simple state, input output state in Java, right? So as we have seen here, when you look at the state concept, there are two kind of states. Either you use a linear state, or you can use other kind of states also. Linear state is used when you don't want to use any nested workflows, or let us see more reference to linear state. Corda linear state. So in the documentation, Corda state is, you can see the details of the linear state. So a state, that evolves superseding itself, it is a linear. So there could be abstract state, linear state. So when you go to contract APIs, you can see that there are abstract. Let me. Yeah, there is transaction state, linear state, and so as this is the API reference of Corda. So as you are seeing here, there is something called linear state. A linear state is a state that evolves by superseding itself. Then there is something called a transaction state. Transaction state is a wrapper for contract states. So when you see contract states is a state containing data used by a contract program. Very straightforward. And then it is used in a workflow scenario. And there are other states like fungible states, queryable state. It is an important state we use. Schedulable state, queryable state, ownable state. These are the other states. So in some of the applications, we had used queries on contract. When you do reporting on Corda, we do queryable state. When you are scheduling a transaction, when you want a particular reporting transaction or monitoring transaction to happen repeatedly, you can use schedulable state. So we mentioned we can also use fungible state. Fungible states are for things which are fungible. So this means that they can be tokenized, split, or merged. So anything that can be fungible, like in the case of some financial assets, stocks, or some other commodities which can be split or merged, they can be represented by fungible state. We can also have linear states. So getting back to the source code, So here we are using the linear state. We can also use the and also there is an identity mentioned, unique identifier, and here we are defining the party as abstract party. Then the schema is invoked. We mentioned the database schemas used. Here we are using the concept of map schema, and here we are persisting the state. We are also using queryable state. Okay, and so we can see this particular example is showing a linear state example with queryable state. Initially we define the attributes, we define the parties who are going to be part of this transaction, and what is the kind of ID that we are going to use it here. The asset value we mentioned here, and then we create the constructor, and in the constructor we pass all this. This is a parameterized constructor. I think there is a comment. Yeah, I'll give that link. So this is the link. This is the Corda API documentation. So you can see all this API documentations here. Okay, so fine. So back to the code. So now we have the parameters. Yes, any other comments? This is the API. Okay. So after initializing the constructor, now we are going into the annotations, and then we are creating the persistent state method. So we are passing the schema as an argument to the persistent state. Essentially, Corda uses Hibernate object relational mapping internally, ORM. Some of you may be familiar with Hibernate. Hibernate framework is used for database mapping the state objects into the Corda's database. So then we are referring to IOU schema, and here it's actually loading the schema. So this is a very simple example of a state where it's defined as a linear state, and it's also a queryable state, so you can query it. It is also a persistent state. Okay, now we are getting back to the other code examples here. It seems my machine is a little slow. Yeah. Now let us see a contract. So sample code download, I will give the command. So you can use the command. Let me give you the command. Okay. If you can use this, I will show you the command. This is I will write to. You can type git clone with giving the repository name. So there are two repositories I just pointed out today. One is the old repository. We can also use the latest repository. I will show you the latest repository also. So this is the latest repository. You can also download from here. This is the command. repository. I hope you got that command. Okay, because the new repo contains so many new apps like auction app, auto payroll, bike markets, car insurance, uh, token, an example Corda token, also an example for how to upgrade Corda node, also an example of fungible tokens, also node monitoring heartbeat example, also examples for a Corda app with the React front end, another example of a negotiation Corda app, an example of an Oracle ping pong game, and an example of how to use web server, Spring Boot along with Corda to develop Corda apps with Spring Boot. Okay, so all these examples are there. So, let's get back to the Corda code now. We will get back to the Corda. Yeah, so let me show you. A Corda contract. When you look at this Corda contract, a contract refers to the state. It is important to know about the concept of commands. You can invoke contract or you can pass arguments to contracts using commands. You can call, so you use commands with parties, command data. You can retrieve the data from contract through command. So this is the concept of command, Corda contract commands. Yeah, I think the command, yeah, this is the example of command. So I'll just mention to you what is command. So command data content. So you can retrieve so basically commands are used. We use commands to trigger contracts or to control the contract. Okay. So now when we come here, we invoke the state, and we also have the command data. Also, we have the abstract contract example where it says what is the contract. And then we also use the abstract party, right? Abstract party. And then ledger, we also invoke the transactions here, ledger transactions. And then we use the collection, the stream, Java Stream API collectors. And we also use command here. Corda has a domain specific language framework that is parsing how is your contract parsed? The contract are enforced through the DSL, domain specific language. Okay, now we see that IOU contract implements the contract interface, and then it is a type of, so also we annotate the contract ID, and then there is a verify. In this class, we have a verify method where we pass the command. So you call the contract through command line, and then you can, the details of the command can be retrieved through get commands. And then this is very important. You give generics. So the concept of generics is very important in contracts. These are the generic constraints used. So the validity, validity that only one output state should be created, and no input should be consumed when issuing an IOU, and ledger, and making sure that the same entity cannot do the both lending and borrowing in this transaction. So if all of these conditions you write in your constraints part, and then yeah, so you are also extending the basic command data here. So whatever uh, you want to write, you can write here. This is the example of a contract. Now let us see a flow. Yeah, so how to run the command. So if you have downloaded it, if you have downloaded the link, I will give you the step again. I have mentioned it earlier. So the step to run it is by running a command called gradle w deploy node. That is the command you run to deploy the node. Once you download the sample, please through Git please go to the samples directory and run the following command. I'll run it again and show you. So once you downloaded your example, you have to run this command. If you are in Linux, start with dot slash gradle w deploy nodes. If you are in Windows, you just type gradle w deploy nodes without dot slash. This is the command to build the sample. I hope that is clear. Dot slash gradle w deploy nodes. I hope you can see it now. This is how you build your sample Corda. Okay, so let me show you another example. I have also another example here. See, let me go to Corda samples. this is another example code. Here also I can run the same command. So the command is common. Here it's an example of a insurer and insuree. This is the example we are running. So this is an example code for a queryable state where we have a notary, an insurer party, and insuree party. Okay, so I hope this is clear. Now we have seen the, now let us go to the Corda flow state, flow framework. So flow is a little bit more advanced. State is the simplest one to write. Then uh, we have also seen how we can use contracts, how to write a contract. And then we have also seen how to, what are the essential packages we use there. So Corda flow framework is built on a particular Java concurrency library known as fibers. Fibers and quasars are two important Java concurrency libraries used in Corda. Fibers and quasars. We can see how fibers are used here. And then here we are seeing how the flow invokes a contract. We are also invoking the state. So contract is there, state is there. We are also using the collection framework for using the immutable list and set, which are the two data structures used here, right? And then we pass the contract state. It is important. We have, even though we constructed the contract as a linear contract, when you're used in the flow, we are passing the contract state. So contract state becomes the wrapper for everything that we do in the contract. Contract state model. Okay. So, and then we import the Corda's flow library. We also import the party, the identity of the party. And here it's important, we also use transaction builder package. Transaction builder is also an important component. We can also monitor the particular transaction using progress tracker. So here, and we are importing the contract ID. We are also validating the contract using require that DSL. So this is an example flow. We are making this flow as a initiating flow, and we are. This is an important part. This flow is something which can be startable by RPC. So when you design clients for Corda, client can be either RPC based client or REST based client. In some web services, we use REST, and in some of the interactions we use RPC, like JSON RPC, XML RPC, etc. These are examples. So some of the low level remote call, RPC means remote procedure call. When you have a remote method invocations, remote calls by clients over, for example, there could be IoT clients which are invoking transactions through XML RPC or JSON RPC or MQTT. But this is an example where this particular flow can be started by RPC. Okay. And then we are, in this class, we are actually extending the flow logic using initiator. We are, declaring the private variables, private constants here. And then we are also invoking the progress tracker. And finality flow is an important concept in Corda. When finality flow, it's called you should know what is a finality flow. Corda. So not every flow is a finality flow. So a flow is a finality flow which is actually verifying a given transaction and sending it to the notary. So any flow which you finally send it to the notary is called finality flow. So a notary, so like earlier we mentioned, if the transaction is acceptable, before committing to the ledger and writing it to the vault, that the final flow, the final state in so any flow which you want to make sure that you're finally entering into the ledger and the vault, then you design it as a finality flow. So these are the type of objects that we use. These are the type of constructors, different ways to invoke finality flow. And then what you also see is this finality flow can be asynchronous. That's why we use await. These are the conditions we check when we implement a finality flow, like whether we should check whether the flow is killed or not, whether we have sufficient permissions. We can get all the flow information, whether it's an initiated flow, is it a persisted flow. So all this are the important properties of finality flow, which we can configure in our flow. Okay, so there are receive finality flows. This is a specific kind of finality flow. Before that, we should understand what is a flow session. Flow session is a handle between a pair of flow. This is something you should know when you are when you want the information from flow session, or when you want more details about it, you use flow session. Receive finality flow is a counterparty to finality flow. This is called receive finality flow. So when you get back to the code, here we see that so the output from the progress tracker will be an detail that you get as a finality flow output. This is the return type. So essentially here we are configuring the progress tracker. So progress tracker is a checkpoint on the flow. So this helps us to monitor the flow. So this is how we initiate this flow, through this initiator method. And then it is important to know there is a transaction declaration in the flow. Suspendable is an important concept we use. What suspendable flow, Corda? This is related to the concurrency. When you make a particular flow suspendable, yeah, so suspendable means you can, so this is the reason why we use suspendable. This is part of the Quasar concurrency framework. So flow framework internally uses something called Quasar. So Quasar is a particular Java concurrency library used in Corda, and then it creates a way to jump from suspended transactions. So you all of you used multi-threading in Java, right? So you can there are threads which you can suspend. There are threads, processes, and fiber is another concept like thread. At the JVM level, we have threads and processes. So here, Quasar helps us to transform so whenever you give the annotation suspendable, it transforms the bytecode. such that you are able to, so Quasar agent will look for the functions with suspendable annotation. And then when it is suspendable, what it does is it will run, it can halt it for some time and start it, resume it after some time. That is what it does. So I can tell you more about Java Quasar and Quasar, fiber and thread. These are the concepts you should have a good clarity when you engineer Corda. So Quasar, fiber, so this is implemented by the company called Parallel Universe. So Quasar is a library that provides lightweight thread. So this is similar to the actor model of Erlang. Erlang is one of the first concurrent language. In fact, Erlang came after Java, but Erlang introduced concurrency way before Java. And in Go language, we use the concept of channel. So Quasar introduces asynchronous lightweight threads. So, there is a good article on this. I think I'll share in the chat. There are a lot of questions. Yeah, Java Quasar. This is very Quasar is used in Corda flow framework. This is the reference to it. You can read more about it. It is written using some of the code Java utilities built by Google and a symbol logging framework and ASM framework. So, you can understand more about fibers here. So, okay, let's get back to, Quasar is it's also implemented in Kotlin. And then, so, we don't have the time to go through the detail of this. That's why I'm just taking back to the code. So when we get back to the code, see this transaction, this annotation is very important, suspendable. So when JVM reads this suspendable, then it will invoke the Quasar agent. And then we are, so this, when it is, this particular sign transaction is invoking the notary from the network map. So in the service hub, you have the network map service, and then you get the notary identities. You pass it to the notary object, and then you reach the particular step in the as per the flow framework, and then get the identity of the party. Then you also retrieve the state object. Then you get the contract command. So you call the contract by the command, and then you are calling it as an immutable list. You get the details of the contract calling party, like here it is borrower and lender. So lender's key, and you are passing lender key and borrower key. So both source and destination key are passed to it. Now you are also invoking a transaction builder. So this is how you build a transaction. So in the transaction, first you get the details of the network map, and then you get a detail, pass it to the notary. Then you get the party identity. Then you call the state, call the contract with commands, and then you do the transaction build. And thereafter, you are you're reaching the current step of the transaction. So now you are in the verifying level, and now you are initiating the transaction signing. So you are initiating signing the transaction. Now you're gathering the signatures from all the parties. So now you, after gathering all the signatures, you are initiating the flow. And when you're initiating the flow, you collect all the signatures and sign and all the sessions from parties as immutable set, and you collect the signatures through progress tracker. Now you're finalizing the transaction, you're calling the finality flow, which we have seen. Now there is the concept of acceptor in a flow, Corda acceptor flow framework. It is a particular data structure used for in the flow logic. So acceptor is used mainly as part of the flow logic. So when we see the API, so in the flow logic, you are seeing, its acceptor is actually basically it's an approver. Whenever we want a particular party to approve a particular transaction, we invoke acceptor, and basically here also now we are after defining the acceptor class, we are referring the acceptor class. Now we are again calling the signed flow. Once it is approved, when there is a signed transaction flow, we can check the transaction. So when you are checking the transaction through constraint, here we are using the DSL to domain specific language to verify a transaction, whether it properly, so you are checking the output from the signed once the transaction is accepted. This is what happening at the last level. So this is an example of a flow framework. Okay, so if you have any questions, we have seen 3 important components till now: how we write the state, how we write the contract, and how we write the, we saw how to write the state, how to write the contract, and what is about the flow framework. We have also seen the internals of the flow framework. If you have any questions till now, please raise the questions. Otherwise, teachers, if you want, you can break for lunch now, and then we can resume our presentation and go deeper into the concepts that we have learned till now. Any questions till now, teachers?
Participants can either ask the question or directly ask the question, or put the question in the chat box.
We can have the questions at the end of the session. Yeah, definitely, yes. So, but now, otherwise, shall we break for lunch, teacher?
Yes, yes, sir, definitely, sir. So thank you, sir. We will be resuming our session exactly at 2 p.m. So
that's right.
So participants, we can break for the lunch.
Thank you, everyone. Let us break for lunch and we'll resume at 2 o'clock.
Feedback link will be provided by the end of afternoon session. Gokul sir will be resuming the session in the afternoon also. As the same resource person is resuming the session afternoon also, the feedback link will be provided at the end of afternoon session.